Dear students, in this video lecture, we will study about network topologies used in the distributed embedded system and networks for embedded system. This is a second topic from module 6. And the network abstraction layers. Already we have covered this topic in the previous video lecture. Let us see what are the different or various OSI layers. There is 7 layers: physical data link, network transport, session presentation and application layer. We have already covered this in the last video lecture. And let us study about the network topologies. The first one is point-to-point network. A point-to-point link establishes a connection between exactly two PEs. Point-to-point links are simple to design because they deal with only two components, that is PE1 and PE2, link between these two, and the other link 2 means PE2 and PE3. This point-to-point networks. And the second one is bus network. A bus is a more general form of networks since it allows multiple devices to be connected to it. PEs connected to the bus have addresses. Communication on the bus generally take the form of packets. A packet contains an address for the destination and the data to be delivered. It frequently includes error detection or correction information such as parity. It also may include bits that serve to signal to other PEs that the bus is in the use. The data to be transmitted from one PE to another may not fit exactly into the size of the data payload on the packet. It is the responsibility of the transmitting PE to divide its data into packets. The receiving PE must, of course, reassemble the complete data message from the packets. Distributed system buses must be attributed to control simultaneous access. Arbitration scheme types are summarized below. Fixed priority arbitration and fair arbitration schemes. There are two types of arbitration schemes in the bus arbitration, that is fixed and the fair. Fixed priority arbitration always gives priority to competing devices in the same way. If a high priority and a low priority device both have long data transmissions ready at the same time, it is quite possible that the low priority device will not be able to transmit anything until the high priority device has sent all its data packets. And the second one is fair arbitration schemes make sure that no devices is starved. Example, round robin arbitration is the most commonly used of the fair arbitration schemes. The PCI bus requires that the arbitration scheme used on the bus must be fair. Although it does not specify a particular arbitration scheme, most implementations of PCI use round robin arbitration. A bus has limited available bandwidth. Since all devices connected to the bus, communications can interfere with each other. Other network topologies can be used to reduce communication conflicts. And the next one is the crossbar network. In this crossbar network, a crossbar not only allows any input to be connected to any output, it also allows all combinations of input-output connections to be made. Example, we can simultaneously connect input 1 to output 4, input 2 to output 3, input 3 to output 2 and input 4 to output 1 or any other combinations of inputs. Multicast connections can also be made from one input to several outputs. A crosspoint is a switch that connects an input to an output. To connect an input to an output, we activate the crosspoint at the intersection between the corresponding input and output lines in the crossbar. Example, to connect input 2 and output 3 in the figure, we would activate crossbar. The major drawback of the crossbar network is expense. The size of the network grows as the square of the number of inputs, assuming the number of inputs and the outputs are equal. And the next topology is multistage networks. Multistage networks have intermediate routing nodes to guide the data packets. They are a class of high-speed computer networks usually composed of processing elements PEs on one end of the network and memory elements on the other end, connected by the switching elements SCs. The switches can then use their own routing algorithm or controlled by a centralized router to form a completely interconnected network. And let us see how message passing occurs between nodes in a distributed embedded system. Distributed embedded systems do not have shared memory. They communicate each other by passing messages. Message is broken into packets to send on a network. Procedural interface for sending a packet is send packet address and message data of I. And clever encoding techniques may reduce the length of the message so it fits into a single packet. If the message is a shorter than a packet or not, and even multiple of the packet data size, some extra information may be packed into the remaining bits of the packet. Reception of a packet will probably be implemented with interrupts. Network protocols encourage a data push design. And this is the overall architecture of distributed embedded architecture, and this figure is from our textbook Raj Kamal 3rd edition. Okay, thank you.